Hello, good day. Let's go on practicing. The four women, Anne, Betsy, Charlotte and Dolores, and the six men, Eric, Frank, George, Harry, Ian and James, are friends. Each of the women wants to marry one of the six men. In how many ways can this be done? Let's list the four women and the six men by their initials. Now, how many ways for A to marry one of the six elements, A, F, G, E, F, G, etc., etc.? There are 6 ways. How many ways for B to marry one of the elements except the one that has been already chosen? 5 ways. How many ways for C? 4 ways. How many ways for D? 3 ways left. So 6 times 5 times 4 times 3, which is 6 factorials divided by 2 factorials, which is 360. And the exercise is solved. This model is dispositions without repetition of 4 elements in a set of 6. Also because you can see the problem, the model, this way. Let's pretend that every letter here is simply a slot, a cell, a box. Okay, so you have 4 boxes here to fill in, 4 blanks to fill in. In each blank you will write one of the 6 letters. For example, in the first slot you can write F, let's suppose so. In the second slot, in the second blank, you will write J. In the third you will write E. You are writing a sequence of 4 letters chosen among these 6 letters. So you have written, you are writing all the sequences of 4 elements without repetition in a set of 6. Without repetitions are said because every woman will choose a man who has not been chosen yet. Okay, so A and C will not choose the same man. This will not happen. So letter E will not be written in 2 blanks. Okay, so no repetitions. So that explains why this model is a disposition of 4 elements in a set of 6. Finally, speaking about women that marry men is the same as speaking about functions between sets, which associate to every element of the first set one element of the second set. So let's see then the exercise from the point of view of functions and set. The first set will be called domain, and the second will be called codomain. A function from a set D to a set C is an application that associates to every element of the first set of D one element, one and only one element of the set C. So an element from set D will have an image in the set C and only one image, so it cannot have 2 images. Okay, this is the definition of a function. In the definition of function, it is not required the vice versa. So it is not required that also for every element in the set C there will be a counter image in the set D, so that for every element here you will have one and only one element in the set D. This is not required, but if that happens, the function will be called biunivocal or bijective or one-to-one function, one-to-one correspondence. Okay? Now, let's revise the definition of injective function and surjective function. An injective function is a function where for every element of the set C there is maximum one counter image or one pre-image in the set D. So you will not find this situation. Okay? This does not happen in an injective function. If this happens, this is not an injective function. That means basically that two women will not marry the same man. A function is surjective when for every element of the set C there is at least one counter image or pre-image in the set D. So no one of these elements will be left alone without a counter image. So it is clear that if a function is both injective and surjective, it will be bijective or biunivocal or one-to-one, because for every element of the set C there is maximum but also at least a pre-image. So there is exactly a pre-image in the set D. Okay? Okay, so now in this exercise we are asked how many functions are there from set D to the set C which are also injective, because every woman can marry a man and two women will not marry the same man. Okay? Look out, we are not asked that the function should be surjective. Indeed, it will never be surjective in this case, because you have 4 elements here and 6 elements here, so there's no way to have a surjective function, because some men will be left alone anyway. There are too many. So how many of such functions are there from set D to set C? 360 such functions, as we said previously. Finally, what if B were composed by 6 elements exactly the same as C? So in this case the dispositions would be without repetitions as well, but of 6 elements in a set of 6, which is 6 factorial. Basically the question is the same as how many functions are there from a set D of 6 elements to itself. So it does not matter that the name of these elements is different from the name of these elements. So the number of functions of a set D to itself is the number of permutation of its element, so 6 factorial. Enough for now. Have a nice day. See you next time.